In Module 7, we are going to be focusing on the now what, really determining those next instructional steps and strategies. So after we collect evidence of where students are toward these learning targets, what does it look like when we really intentionally determine those next instructional steps and strategies? And we will be seeing an example of this within this presentation. So just a reminder, as we think about this informative or formative assessment model, we start with those clear learning targets. We engage students in tasks, questions, assessments, activities, and students are constantly self-assessing. We're providing feedback, and this cycle includes making decisions about those next steps that we need to take to help students continue to advance and move forward in their learning. So 3 key processes, if we really kind of sum this up, is where are the learners, where are they going, and how are we going to get there? So the last 2 things we're taking a look at within this list is really remembering where are they going, and then the idea of, so how are we going to get them there? What is it I need to provide them opportunities to do and engage in so that their learning can advance? Just a reminder, professional learning communities work hand in hand with the informative assessment process. And you really will see the power of this, and I want you to make connections to this as we go through our presentation today. Collaborating with colleagues is necessary as we think about making decisions about instruction and activities. Starting conversations with your colleagues and making decisions around student data is so powerful. The PLC process really believes in this, that through our colleagues we can brainstorm and be transparent with one another and talk about what would be best for students, and what is it we know, and what would be good for those next step instructional decisions. So this is not a separate idea, but really is a critical component of making instructional decisions. So there are lots of different instructional strategies, and there's no possible way for us to bring them all to the table. But really just be a learner and a researcher. As you work in your content area, being willing to seek out other ideas and read the research is really powerful. And then, like I said a minute ago, really being willing to be transparent and learn alongside your colleagues. We all have strengths and weaknesses, and I think we can really just learn through one another. And then also, as we talk about next instructional steps, really thinking about those misconceptions. You know, as we bring those misconceptions to the table, what you're going to notice is that bringing those out and having kids engage and have discussions around those misconceptions can really lead to deep learning. So keep that in mind, that as you're planning next instructional steps and instructional activities, always thinking about where are common misunderstandings, and in the data, what misconceptions do I see? So here's a fraction example that I'd like to just share with you. Keeping in mind that this is one example, all right, but I wanted to kind of give you that big picture. So we'll start with the learning targets. The learning targets for this example is I can identify a unit fraction as equal-sized pieces of the same whole. I can compare fractions through reasoning and benchmark strategies. So as we think about collecting evidence towards our learning targets, it's to determine where students were in their learning of these fraction targets. So to do that, they engaged in a short clicker activity. Clickers are paper clickers. Students hold up their special clicker card that's assigned to them to respond to the answer. You can see that the focus is on unit fractions and comparing unit fractions. So not only did students respond to these 4 questions via their Plicker cards, but during this use of the Plicker cards, students had opportunities to pair, share, and justify their thinking within the group prior to revealing the answer within the Plicker system. So it wasn't just about collecting the data, but I did take opportunities to have discussions, have kids clarify their thinking and their response. So here you can see they're using these cards, holding up their answer by turning their card to the specific direction it needs to be to choose, let's say, A, and then the teacher scans the cards to collect the data. So here you can see the results of these 4 questions. When I collect data, I think what's really important is to keep in mind that you want it to really provide you good information. Too often when I've used rather large assessments, it's hard sometimes to filter through the data. My questions are very specific in seeing if students even understood that a unit fraction had to be an equal size piece within that model, that pictorial model. Then it moved on to more abstractly thinking about comparing unit fractions. And then kind of a little bit further into we can decompose a fraction into unit fractions. Okay, so kind of a little bit of a push there. So this data was really valuable to me. As I looked at this, I could see that students were in different places with these ideas and towards these targets. So we have learning targets, we elicited or collected the evidence, and now what? I don't know about you, but sometimes it's a little overwhelming to actually recognize that we really are all over the place, and that happens more often than not. And so what do? What are those next steps that we might take? So here's an example of what I did with this data. And I'm always reminding myself to be intentional. Be intentional with the time. Be intentional with engagement and learning formats, be it group, whole group, small group, independent, partner. Even my warm-up time, be intentional. Make good instructional decisions to utilize that time and not just make it busy work or it is the next page of the book, so that's what we're going to do. But rather based around those learning targets and where students are. So one of the things that I made a decision about was kind of the go to them idea, getting some one-on-one time. And if you remember in the data, there was one student who got this question incorrect and is not understanding that all 3 pieces needed to be equal. So during our whole group learning, I am going to ask the student to show 3 equal pieces using Cuisenaire rods. I will then ask him to show me 3 pieces that are not equal. Would these be thirds? Why or why not? So my vision is that I am very intentionally, while we're doing a whole group activity, I'm just going to go to this particular student and we're going to work through kind of thinking about equal size pieces. This is not going to be a lengthy one-on-one, but a very intentional, let's take a look at this and kind of bring about that misconception he has about unit fractions. So if we take a look at this question, what is the name for each equal part? You can see that the correct answer is 1/6. Now some of the students did indeed struggle with this idea, not being able to recognize what to call that. It looks like many students called it 1/2. Other students referred to it as 6. And so not really looking at each equal part. So in regard to that question, since quite a few students struggled with that, every day we do a short 3-minute warm-up. It is not the spiral review, it is not the warm-up questions typically from the text, but rather based on what they're showing me and some little struggles they might be having along the way, I embed these warm-up questions very intentionally. So simply during our warm-up time for a few days, we're going to do some pictorial representations, talk about unit fractions, what does each piece represent, are they equal, just some very short but purposeful questions along with discussions. Typically, they do these first within just a math journal. They put the date and their response, oftentimes pair sharing, and then we come back together as a group. So really, it's usually just a couple questions with them responding independently, and then eventually we bring those out as a whole group. So the next decision that was made was I decided that the next day we would begin our day with just a whole group mini lesson. Students will be partnered up and each pair will get a card with a fraction on it. They will do a think, pair, share, and then decide where to place the fraction on the number line. So there is a number line from 0 to 1, and together students will decide where to place that. So we will have not just placing these, but lots of opportunities to discuss with partners, for me to listen, and then as we come together as a whole group to really kind of critique the reasoning of others and justify why we're placing it where it is on that number line. So this will be a whole group activity. I will be pretty intentional about which fractional quantities pairs and students get. Partnering will be intentional as well. So oftentimes during these whole group mini lessons, it's easy to differentiate kind of the complexity of the, in this case, fraction card you give a student or pairs of students based on where they are in their learning. So for my struggling student that's not even sure what a unit fraction is, I might give that student the 1/2 card in this whole group activity, for example. So you can see that we start out with a little 3-minute warm-up. We do a whole group activity where we're all working on the same task for about 20 minutes, using vocabulary to discuss our thinking and our ways of placing the cards. And then we're getting into some small group rotations. As I was making instructional decisions, you can see from the data that some students understand unit fractions and comparing fractions, and others don't. So for 2 days, I will do some small group rotations in which some students will be extended while others are working on understanding the targets relating to comparing fractions in particular. So this is kind of a look at our first day. So you saw what the whole group looked like. Stations and rotations will focus on problem solving with unit fractions, comparing fractions, an iPad app that has students connecting visuals with fractions in order to compare them. So these learning centers are going to be very hands-on, game, iPad apps, problem solving, so very much a mix. So I'm not going to go too much into what they are doing at their rotations, but they're focused on the learning targets, and my station activities are things that I know they can do independently and that have variety. So you can see that there's a little technology, there's some partner game time that they'll have, and then there's some problem solving that they're going to do. And during these 20-minute rotations, the teacher, I will be working with a small group. So as we think about these 20-minute rotations, and in this case there were 3 groups, very flexible strategic grouping. So group A, those are those students that have mastered the learning targets, and they're going to do a problem-solving task that has them ordering more complex fractions within a math task. One of the strategies they're going to use is what's called a placemat activity. That really gets all students engaged in the process, explaining, thinking, showing their work. Group B, those that got the 3/4 is the same as question incorrect, will use manipulatives to show all the different ways that they could decompose fractional quantities into unit fractions. They'll make connections to the pictures and to the fractional numbers, because one of the key components of math differentiation and grouping is oftentimes students are just at different places in their learning when it comes to the representations of concrete, pictorial, abstract. So our job is to really help students connect the dots between those three. And sometimes students are just not quite ready to move to the abstract yet. So when I work in small groups, sometimes my activities don't look that different, but they are different in the sense of representations of concrete pictorial abstract. And then group C, really those students that got 3 out of 4 of those questions incorrect, we are really going to be working on unit fractions using those Cuisenaire rods as a tool to help them see those equal size pieces and the number of pieces within one whole. So basically, if I go back here, students will each have a 20-minute opportunity to work within a small group with myself, with me, the teacher, while other students are doing purposeful, meaningful activities in learning centers. So once that time is up, approximately 60 minutes, we come together on the carpet, and it's where we bring meaning to the activities that we just did. You know, too often I feel like when we do rotations or stations, we don't take the time to come back and discuss what strategies did you use as you were working on the iPad app, what were the models that represented the unit fractions, how did they help you, for example. So it's really about them being able to share strategies, thinking, what they learned, where we can all have a meaningful conversation about the targets we were working on and what we learned. So this is a really important part. It probably can take, once again, 3 to 5 minutes, but it connects the math with the activities. Okay, a lot more bang for your buck when you're working on those rotations. So remember, you just saw an example of fractions and working towards specific learning targets and planning specific instructional steps. Really thinking about where are they going, and instructional steps for how to get them there. And I think one of the key words you heard in this presentation was just being very intentional. Sometimes we were really strapped for time, and I think thinking through the learning formats, meaning whole group, small group, centers, what structure is going to work the best, and then what are the activities that will really get them to the learning? What are the instructional strategies that will help them advance forward? So hopefully that example, one example, was helpful to your own thinking process of getting to those next instructional decisions.